Okay, so today we have 4.1, 4.2, climbing stairs using rise and run, and finding slope of a line. Sorry to be absent 2 days in a row. It was not part of the plan, but hopefully I can get this lesson across and you guys can watch it over and over again because math is that awesome. So go ahead and write this down. 4.1, 4.2, today's October 11th, and then your page number. Pause it if you need to so you guys can copy it down, and we'll move on. Okay, so we're putting this on the same page. Sorry, this date is off. So is page number. But 4.1, climbing stairs and finding slope of a line. And our focus question is, how can you find the y-intercept and the slope of a line from data in a table, graph, or equation? How is the steepness of a set of stairs related to the straight line of a graph? Okay, so the most important part of this is being able to identify it in a table, a graph, and an equation. We have to identify it in those three parts. Okay, so we've used all three of those things before. Now we're just going to identify the slope. And we've done it before. We're just going to do it again instead of notes. Slope. Slope is the number that expresses the steepness of a line. Okay. Now we know what the steepness of a line is, and now we're just going to associate it with a numerical value. The slope is the ratio of the vertical change to the horizontal change. Okay. Vertical, that's our y value. This is vertical change. Okay, vertical. And our x value is our horizontal change. Okay, so it is a horizontal. Okay, there you go, I think. So this is a ratio, so this should be expressed as a fraction. Okay, there should be a line in between these two. Change in y over change in x, rise over run. Y is how much vertical change there is. Here it is again. Okay, if you look at the example, our vertical change in a set of stairs is how much it goes up. That's our change in y. It's going up a certain amount or down a certain amount. And our horizontal change is the left and right change. Now, we've done this before. If you look in your notes, it should say something like this, where you have slope is equal to, and we use their Greek symbols, change in y, delta y, over change in x, delta x. Okay, we wrote this once, and some of you guys were confused with these triangle symbols. That's delta, which means change. Okay, that can also be expressed as, let's write this over here. Change in y over change in x can be y2 minus y sub 1, not y squared. Okay, that's not y squared. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the second y minus the first y, the second x minus the first x. This is this change. These are the same. Change in y is this. Change in x is this. Okay. So we're just going to calculate that. We're going to give that a numerical value. In your equation, your slope is always the number that is next to your constant. Okay. It's the number in front of the x. Okay. If your equation was rewritten in a different order, it's still the number in front of the x. So for example, if your equation was y equals 3 plus 5x, this number here, because it's in front of the x, in front of your constant, in front of this is still your slope, even though it's written out of order of our slope-intercept form. Okay, the number in front of the constant. This number can also be a fraction, a decimal, something like that. Good. So here it is an equation, and we're going to look at what it looks like in a graph. Okay, and then we're going to show you what it looks like in a table a little bit later. Okay, now change in y over change in x. Okay, so I'm going to label a couple of these. I'm going to call this x, and I'm going to call this one x, because those are both the first number in our ordered pair, so those are both x's. Since this one comes first, I can call this x1, I can call this x2. This is all our y, and this is our y. And since this is in the group 1, this is going to be group 1, this is going to be group 2. Okay, x2, y2, they go together. x1, y1, they go together. So I'm going to first find our change in y. So let's write this out as slope equals change in y. That's the triangle y. Sorry, my triangles are kind of hideous. Over change in x. Okay, and I'm going to just count it. I'm just going to count what my change looks like. Okay, so first I'm going to draw my line. Let's kind of tilt this so it's a little flatter. Okay, so I'm going to draw my line first from here to there, and then I'm going to calculate my slope. So let's do this. Okay, let's make this a little... All right, so here's my line from here to there. Okay, and I'm going to count my change in x first. So this from there to there, well, sorry, we'll do change in y because that's what we have first. On top is change in y. So from here to there, my change is what looks like to be 1, 2, 3, 4, 5. I have a change of positive 5 because I went up. So my change in y is plus 5. My change in x is just the other direction. So I'm here now. This is my spot. And I'm going to go this way. And now I'm at my final location. I just need to count my change in x, which is 1, 2, 3, 4, 5. So I have a change of 5, a positive 5. So this is my slope right here. Positive 5 over positive 5. Now this can be reduced, and I can say my slope is 1. My slope is 1, because 5 divided by 5 is 1. So positive 1. I went up 5 and went to the right 5. Okay. Now let's do it numerically. Some of you guys are really good at crunching numbers and actually prefer that way. So I'm going to use this equation here. This is our slope equation. Our equation for slope is going to be change in y, which is y2 minus y1 over x2 minus x1 over x2 minus x1. I'm just going to substitute the values that I have in my equation. So my slope is equal to, well, let's look at y2. y2 is 6. I can have 6 minus, that's my y2, minus y1, 1, over 6 minus 1, over 5 minus 0. Here's my x2. 5 minus x1, which is 0. And I get my answer, which is 5 here. And 6 minus 1, which is also 5. I get the same answer as I did earlier, but this is my number crunching method. Okay, this and this are the same. Okay, I counted, that's one way on my graph, and the other way is calculating using my y2 and y1. This is better for larger numbers where you don't want to graph at all. Okay, now I know we said we're going to do it with a table, which we'll do in a second, but I'm going to show it to you through your homework assignment. Okay. Okay, so this is your homework. It's moving straight ahead, investigation 4, ACE questions 1 through 11, odd, 45 and 44 and 45. And then the other one, the additional practice worksheet, which you collected on your way in, page 144 and 145. That one is available for you online in case you lose this one or forget it or lose it or whatever. It's going to be this one, the additional practice, page 144 and 145. You just scroll down to get to those pages. Let's see, is this it? No, even further. 140, 143. Here you go. 144 and 145. Okay, that's your homework. I'm gonna go over the table so we can see what it looks like. Let's see. Here we go. I'm gonna do question 12 with you guys, because in question 12 I got a table and we can identify the slope. Okay, so question 12 says, in exercise 8 through 12, the tables represent a linear relationship, so they do represent lines. Give the slope, so one thing we need to find is slope, and the y-intercept. We've talked about y-intercept before, but we'll do it again. Then match each of the following with an equation. Okay, so this one, we got to match it to one of these equations. Okay, so we'll put it on the clipboard, and we'll put it here. Okay, cool. So let's figure out this one first, and we'll find the matching equation. Okay, so these are all my x's up top. These are all x values. These are all y values on the bottom. I'm just going to label this. I'll call this x1. I'll call this x2. This is my third x, fourth x, and fifth x. X sub 1. You know what? I think I should put it up here. X sub 1, x sub 2, x sub 3, x sub 4, x sub 5, etc. On the bottom, I could do the same thing. y1, y2, y3, y4, and y5. Now I know my slope is y2 minus y1 over x2 minus x1. Now that's just a generalization of 2 points. I could choose any 2 points I want. I can do x5 minus x3. I can do x4 minus x1. That's fine. I'm just going to choose two numbers. It doesn't really matter. I'll stick to y2 and y1. So my slope is going to be y2. Well, y2 is right here. 14. Oh, sorry, negative 14 minus this number, negative 11. And then my x values are going to be x2, which is 3 minus x1, which is 2. So I end up with a slope of, let's do that. Well, 14 minus negative 11, the opposite of minus, this becomes a plus. 14 and positive 11 gives us negative 3. Negative 3 over 3 minus 2, which is 1. So our slope is negative 3. So I'm going to put slope equals negative 3. So in my equation, y equals something x plus b. This is my y-intercept. Okay, the number here, this is my slope. So if I put this here, you know what, let's do this. I'm going to erase this. Y equals slope x plus y-intercept. That's better. And then y-intercept goes there. This I know is going to be negative 3, because that's what we just figured out. We just figured out that this is negative 3 right here. Good. Well, let's look here and see, find a negative 3. Here we go, negative 3. It's a good start. I don't see anything else with a negative 3, so I'm pretty sure that's going to be it. But they tell us to identify our y-intercept. Our y-intercept is the constant, the number that has nothing attached to it. So this must be our y-intercept. Okay, that's our y-intercept. Now, the other option is to input x equals 0. So if x equals 0, then y, oops, let's get rid of that. Let's move that down a little bit. Then, this is our if-then statements. If x equals 0, then y equals y-intercept. So I can write this equation and plug it in. Y equals negative 3 times 0 plus unknown, and my answer will be my y-intercept. To be continued in video 2.